Right, thank you. So, first one, pH scale, a measure of the acidity or alkalinity. Okay, it's a measure of the acidity or alkalinity. It says here, draw one line. What I'm going to do is I'm going to talk through the important things. I'm going to use two different highlighters. One is the command and what it asks you to do, that's the yellow, and the other is the orange is about sort of important information. So draw one line from each solution to the pH value of the solution. Now, we've been doing pH values since you were in year 7. So very quickly, acid. Who wants, basically just choose somebody quickly to tell me what the pH of an acid is. 5. And the pH of a neutral. 7. Right, nice and easy to start you off there. We shouldn't really get those wrong. Now, what you do need to bear in mind is if you make a mistake... Yep. I can, I think. What am I doing wrong, sir? You just do that for me. Is that better? A bit more. A tiny bit more, sir. Is that it? Is that better, miss? Yes. Thank you. Right, so... when you've got something like this in a multiple choice, you can have 3 boxes and 4 answers. They won't generally give you an exact match. What you must do is, the only thing I'll say when you're doing this is if you make a mistake and you've done something like this and think, oops, you cross it out and you make sure you put not this one or something like that. So you make it absolutely clear because there's a real human mark in these and they need to know exactly what you're doing. So cross it out and put something like not this one, something like that. Now, this next one could be a little bit tricky because of the language that it uses. So it says, which ion in aqueous solution causes acidity? Now, there's two things there that you may not know. What is an ion? So if you don't know what an ion is, you can't answer this question, but you can have a good guess. It's one of these, so an ion. So these are ions. What can I see about these ions? What have they all got? They've got a letter, and what else have they got? Plus or a minus. And what do we call that? It's a charge. So an ion is a charged particle. Okay? And then we've got an aqueous solution. Now, aqua, we know, is to do with water. And a solution means something's dissolved in it. So an ion in an aqueous solution means something that's dissolved in water. So what this is saying is which charged particle dissolved in water causes acidity? Yep, there we go. So I'm going to show you some acids here very quickly. I've got an acid called HCl, which is hydrochloric acid. I've got an acid called sulfuric acid, which is H2SO4. I've got an acid called nitric acid, which is HNO3. So these are all acids, and they've all got something in common. And if we look at them, what have they all got in common? What's each one got in? H. So the answer is pH. So think about it. pH, it means percentage of hydrogen concentration, and a H is a positive ion. So hopefully you got that right. Now, think about things like that. So these could not be in there. These two, this one here could not be in there, and the oxygen couldn't have been them because it isn't in something like HCl. Next one. Just make sure I'm getting this right. There we go. When sulfuric acid is added to sodium hydroxide, a reaction occurs to produce 2 products. We've got our reaction here, and we've got the products. These are the products here. Okay? This one, H2O, is water. Okay? So we need to know what this one is. How many elements? Elements are particles that are substances that contain all the same particles, and they're all of them on the periodic table. So, Miss, can you just choose somebody for this one, please? 3. Exactly. Did anybody get 7? It's fine if you did, because if you got 7, you've counted the atoms. They may give you a question that says how many atoms or how many elements? And atoms, you've got two sodiums, 1 sulfur, 4 oxygens. So that's 7. Okay, next one. We've got a reaction. It's an acid and an alkali, nice and simple. What's the answer? Acid and an alkali. What do? We put an acid with an alkali. And it makes, neutralization. It makes neutral. Now, this question here is about name the salt produced. So you have, thank you, an acid plus an alkali gives a salt plus water. So an acid plus an alkali gives a salt plus water. This is the name of the salt produced, NaSO4, because we can see salt plus water. NaSO4. What's Na? Sodium. Okay, SO4. S is sulfur, O is oxygen. Anybody know? Has he got it, miss? It's sulfate. Well done. Now, sulfate, if we look at the last part of the word, is ATE. Now, ATE, when we've got that in a compound, means with oxygen. So any compound, like copper sulfate, or I don't know, anything that's got or copper sulfate or copper nitrate, ATE means it's got oxygen as well. So with oxygen. So just remember that. If there's an O in it, it's with oxygen. Right, next question. Now we're going to look at some command words on here. We're going to identify these command words. Miss will be giving you these command words, and when we're answering our questions, these are from the exam board. They've got all of these words, things like calculate, choose, compare, describe, explain. And they are different ways of answering those questions. And they are very specific. They might be slightly different in some of your other subjects, but for us, they're very specific, and you need to learn these command words on here. So the command word in this one is describe. And describe, it says here, describe how an indicator can be used to show when all the sodium hydroxide has reacted with sulfuric acid. So how can an indicator be used to show when all the sodium hydroxide has reacted with sulfuric acid? So that's the important bit. Now, describe. Describe means to recall facts or procedures accurately. Okay? So if I had to describe what I'm doing now, I would say I am using a visualizer to help students answer GCSE questions. That's a description. Okay? That's a description. Recall facts accurately. Or a procedure. Now, this is asking about a procedure. So I'm going to give you some hints and tips, and then you're going to ask this question. Right, what indicator do we use with this is an alkali, and we've got an acid. What indicator do we use when we want to know about acids and alkalis? Universal indicator. Right, so we'd put it in either in the acid or the alkali, yes? And then what you've got to do is you've got to see how much of the other one takes before it goes what colour? What colour does universal indicator go when it's neutral? Green. Okay, and so neutral equals green. So this is a 3-mark question. So you've got to make 3 clear points. And I do this, and I encourage my students to do it by putting bullet points, because there's a real human marking your paper. And if they can see that you've put 3 bullet points, they can look for the 3 points you've made. And it also helps you when you're answering your question to know if you've made all 3 points. So one thing to bear in mind when you're answering this question is, if I've got a beaker of sodium hydroxide with my indicator in, and I just pour a load of acid in really quickly, I'm not going to see when it neutralises. So just think about how you can do that. Right, 3 clear points. You've got 2 minutes to answer that. Just have a go. How would you do it? And you've got how you would use an indicator to show when all the sodium hydroxide had reacted. And when it all reacts, it will be neutral and green. So what do you do? Quick as you can. Just have a go. So you start with either the acid or the alkali. What do you need to do to it then? 3 marks. Just have a go. Doesn't matter if you get it wrong, because I'm going to give you the answer. But I need to see you writing. Right, miss, or a bit longer?
A little bit longer.
Okay.
Please. Really pleased to say a lot of you are giving this a go.
Excellent. Right, miss? Okay. Right, so the first thing I would say is add universal indicator to sodium hydroxide and you can say in a beaker, oops, sorry, in a beaker or a test, sorry, in a beaker or test tube, but you don't need to say that. Add universal indicator to the sodium hydroxide. Now, the important bit here is add the acid gradually or slowly. Then add, and we've told us what the name is, the sulfuric acid. Gradually. And then final point is until it just, you don't have to put just, turns green. Or so. Or turn, and you'll know it's pH 7 when it's green. Now, the things I've put in brackets you don't need to put, but you do need to say add the universal indicator to the sodium hydroxide, add the sulfuric acid gradually. This bit's important. If you just say add sulfuric acid, you won't get the mark until it just turns green. You could also say until it gets to pH 7 or something like that. Okay? Right, put your hand up if we managed to get all that right. Fabulous. Just one person, really? Okay, well done. Right. Thank you. Shh. Now, what we have here is what we call an extended response question. It's a 6-mark question, and usually 6-mark questions ask you to do 2 things. So we're going to read through this together, and we're going to highlight the important points. A student investigated the rate of reaction is important, between magnesium and dilute hydrochloric acid. They used the apparatus shown to collect the gas produced. So we've got a gas syringe here. The gas is given off in the conical flask when the acid and the magnesium reacts, It then travels up this tube and pushes the syringe out. So you can measure how much gas is given off. So what you've got to say is, what would you do? You're given this equipment, what would you do? So the next bit says, outline a plan. I'll just outline a plan. And when it's talking about a plan, it means a method. Outline a method. To investigate how the rate of this reaction, now these are the important parts, rate of this reaction changed when the concentration of the hydrochloric acid was changed. So what you've got to say is, right, I've got to keep everything else the same, but I'm going to have to change the concentration of acid. And if I gave you this equipment, what would you do? You've got to take the bung out. You've got to put the acid in. You've got to put the magnesium in, put the bung and the syringe back in and see what happens. But that isn't enough for this question, because it's saying, describe, and remember that state facts accurately or a procedure accurately, describe how you would do the investigation. So what are you going to do? And the measurements you would make. That's the first part of the question. And the second part is, describe how you would make it a fair test. And a fair test, it means, what do you control? You don't need to do anything about safety. They're not asking about safety. So describe how you would do the investigation. That's the first part of the question. So what would you do? You've got to think about the measurements you would make. What will you measure with the magnesium? What will you measure with the acid? Just put a value in that seems like it makes sense. How long would you time the gas given off for? Would you just wait until it finished, or would you do it for a certain amount of time? So think about all those things. And then the second part is how you would make it a fair test. What do you control? What things? So you've got acid, you've got the amount of acid, the amount of magnesium, you've got all those things. This is a 6-mark question. I'm going to give you about 5 minutes to answer. So the first part of the question, do about 4 bullet points. What would you do? And you are doing this, it's like imagining you've just done a practical, just done an experiment in your science lesson, and you are describing it to somebody when you go home. So you're telling them exactly what you're going to do. It's just the method, like a recipe. So have a go and say what you would do. You've got the equipment to help you. 5 minutes, please. Put your hand up if you have a question. Try and do this on your own, please. Shh. So you've been given that equipment. Imagine it's got nothing in it. Imagine it's not got acid in it. Imagine it's not got magnesium in it. Shh. So what have you got to do to get the acid and the magnesium in? How much of the acid and the magnesium do you need? Just say any value. It makes sense, yeah? See everybody writing, please. Just have a go. Not got a clue? Isn't it? Remember, year 10, it doesn't matter if you do not get this right, because we're going to go through the answer and you can do corrections. It's not a problem if you get it wrong, but everybody needs to write something, please. Can we just make sure that everybody's having a go, please? Thank you. You can see your equipment. What would you do? Really well done, lots of you really getting on with this. It's excellent.
Guys, there's some chats we need to really focus in, please. And if you're sitting and you don't know anything, just sit quietly. Staff, can I ask you support on that, please?
We right, miss? Another minute.
Yeah, another minute, please. Can I just pick up on a point that a number of you have asked? You do not need to say how you're going to set that equipment up. It's given you the diagram. So don't think you've got to say, you know, collect a conical flask,
None of that.
etc. And you'll see that when Miss goes through the points. Don't worry about how you're going to set it up.
Okay, miss. There's quite a bit of chatting now. If I have a go, wait a bit longer.
Yeah, about 30 seconds.
Right, okay, thank you, Year 10. Can we have you quiet, please? Then I can go through the answer. Right, thank you. Okay, so you do not need, it's not asking you to describe how to set up this. What it's saying is, what do you need to do when you've got this equipment? What do you do with it? So the first thing that we can say, you might not exactly have the right answer as I will, but I will tell you the very important points that will get you the marks. So the first thing is, you can put something like, add dilute, sorry, I made a mistake, dilute acid to the flask, because this is called a conical flask. Add dilute acid to the flask and magnesium. Now, once you've done that, you need to quickly, or just so quickly, remember, you don't need to say quickly, I've put it in brackets, quickly connect the bung to the flask. Now, the next bit is we're talking about measurements. Quickly connect the bung to the flask. Measure the amount of gas given off, and I would say something like in 1 minute. If you've put 2 minutes, 3 minutes, 4 minutes, 5 minutes, that's fine. But I would usually say with something like this, 1 or 2 minutes. So that's, yeah, and that's your procedure. So this first part is your procedure. Now it asks for measurements, and we've given one measurement here, but we're missing some other measurements. So measure the amount of gas given off. So we need to do some more. So this first part is your method. That's this one. We've done that top part. Now, the second part is how to make it a fair test. So we're going to do that now. Oh, I've missed something. What do we need to do? Can we do it once? Because we need to change what? We need to change the concentrations. So we need to repeat this. Repeat for different concentrations of acids. So that bit there, all of that is your method. Now we need to do your fair test. So what things do we need to keep the same? So we need to keep the following the same. The length of magnesium ribbon. That's one of our measurements. The volume of acid and the temperature. There will be other things. Maybe the size of the beaker, maybe the sort of type of acid you could get marks for as well, that sort of thing. So the measurements, I measure the gas, the length of magnesium is a measurement, and the volume of acid is a measurement. So those are the things that you're talking about. That will get you 6 marks. The first part for the procedure and the second part for a fair test. Now, as you can see, I haven't written that much. It's in really very, very simple sentences. And when you're doing a 6-mark question, you need to make sure you've got simple sentences with a capital letter and a full stop. We're going to be doing some more of these. Right, who feels that they've got most of that right? Pop your hand up. Well done, excellent, really good. More than last time, fantastic. Right, next question. Now, there's a lot of muttering. Thank you. Shh. Now, when you're doing a graph, when you're looking at any graph of a rate of reaction, a rate means reaction or something that happens over a certain amount of time. So, oopsie, missed a question. Where's it gone? There's a question missing, sorry. I have missed a question. I think it's on the other side. There we go. That's better. Apologies. Right. Here, you will get questions like this, which ask you to look at a thermometer, ask you to look at a measuring cylinder, and will ask for what the value is. So you need to make sure you understand how to do scales. Can we just do this question very quickly, please? Yep. What is the volume of gas collected? This is the bit of the gas syringe. The gas would come in here. What's the volume? Can somebody tell me, miss, quickly? 6.5. Thank you very much. Right, next question. Right, year 10. We have a nice and quiet, please. Thank you. Okay. Right, now, this, figure 3, shows the students' results for one concentration of hydrochloric acid. Remember, the practical was looking at different concentrations. And this is one concentration. And what we can see here is, now we've got, when we do an experiment, we've got a dependent variable and an independent variable. The independent variable is the thing that I would change. So that's how I remember it. And if we're looking here, we've got the time and we've got the volume of gas. So as the time increases, the volume of gas given off increases. Okay, so this is one concentration. So what we can see from this is time in seconds against gas produced. So what you need to do is you need to plot this graph. One thing I will say before you plot the graph, you've got time here. As the time increases, what happens to the volume of gas? So if you look here, there is no time So therefore, there's no gas produced. So this always must go through what we call here the origin. When you were plotting a graph, I'm just going to show you over here, you either do a cross or you do a cross like that. It doesn't matter which. Do not do a dot. It's not clear enough to see. There are 3 marks for this question. Plot the results and draw a line of best fit. You get 2 marks for plotting the results and 1 for the line of best fit. Look at your scale carefully and have a go. So can you draw that and do a line of best fit, please? Very quickly. Got about 2 minutes. You won't need longer than that. If you haven't got a ruler, just do it as best as you can. But you need a ruler in the exam, and preferably not a stupid one like this, a clear one, and it's easy to draw a line of best fit. Okay, can we do those points, please? I'm going to put mine on now while we're going. Well done, excellent. Everybody's getting on with this, fantastic. Have we done that? Have you done a line of best fit? If you haven't got a ruler, just do your best, but you must remember in the real thing, you need a ruler. You're asked to do this a lot in science. We're nearly done? Sarah, are we nearly done? Yeah. Okay, so let's have a look here what we have. So we've got, what you must remember when you're looking at a graph like this, I like to put arrows on here and here, because what this shows me is that as the time in seconds increases, so does the volume of gas. So learn to read your graphs like that. I'm sure Miss will do, your teacher will do some more work with you on that. So we'll plot this. We've got 0, 0, which is this first one, and then we've got 10 and 35. It's a little bit tricky to see. In between is 30, and in between those two is 35. I'll put my specs on because I can't see myself. And the next one, so we've done that one, 15 and 52. So 15, in the middle is 50, and each one of these small squares is worth 2. So that goes there. 20 and 80, 20 and 80, nice and easy. And 30 and 87. Now, the 87 isn't very easy, but what they'd usually do on an exam like this, you get a really clear graph. You can see the lines very clearly, and it's usually almost a full-size page. So 30 and 87, we've got 80, that would be 85, and it's above that, the 87 in the middle. Okay, now what we can see clearly from looking at this is, we've got certainly one line that's out. You need to start at the origin. Yes? What have I done? Oh, sorry. Thank you. So that's 90 there, thank you very much. So that's 85 and it's just above 87. There we go, that's even better. So what we can see here is we've clearly got a result that doesn't fit. It's an anomalous result. So put your line of best fit in. It needs to go through the origin. As many points either side of the line as you can. Okay? That's your line of best fit. That's 3 marks. Thank you, sir, for pointing that out. Apologies, everybody. Okay. Next question. This is about a conclusion. Give one conclusion. Sorry. So, 2 things we need to look at here. I'm really keen. We've got 10 minutes, miss, yes? 10 minutes, right. So, give one conclusion about how the rate of reaction changed when the concentration was changed. So, looking back at our graph, and what you will have in the real exam paper is you will never have to flip pages backwards and forwards. You will have one page with the question next to it, so you never have to flip pages backwards and forwards. So when we give you questions, we don't always do that, because what they'll do is they'll put blank pages in. So what happened to the rate? So you've got to there we go. So what you've got to say is, you've got to say that as the concentration of acid increased, which is our independent variable, so as the concentration, that's our independent variable. What happened to the rate of reaction? That's our dependent variable. So what do we change to, and what can we measure? So can we just have a go at that question, please? Can we just fill that one in? What happened to the rate of reaction when the concentration of acid was changed? As you increase the concentration of acid, what happens to the rate of reaction? Right, so this sentence, as you increase the concentration of the acid, the rate of the reaction, what's the word I'm going to put in at the end? Increases. Easy. Okay, so that's a rate of anything to do with rate is you've got to talk about something happening over a certain amount of time. So if it's asking anything about rate, it will be over a certain amount of time. Right, I want to have a look at this question because it's a little bit tricky. So it says photosynthesis needs light. Complete the balanced symbol equation for photosynthesis. What we've got here is it has given us CO2, carbon dioxide. It has given us oxygen. So we've got that reaction. So we've got to say, if you can't do the symbol equations, have a go at the word equation. So we've got 6 molecules of carbon dioxide. What reacts with carbon dioxide in photosynthesis? Somebody quickly tell me, and then we can get this question done. What reacts with carbon dioxide in photosynthesis? Water, thank you. H2O. I'm going to balance it in a minute. So that's water. And what does it produce? It produces oxygen and glucose. Right, who's going to tell me the symbol equation for glucose, the formula for glucose? Yes. Perfect. C6H12O6. So we've got 6 carbon dioxides. We need 6 waters, C6H12O6 plus 6 oxygens. The only one you need to remember is this one, because everything else is 6. 6 CO2, 6 H2O, C6H12O6, and 6 oxygens. Now, this next question is potentially a bit tricky, but I'm sure we could do it. We've got about 5 minutes, so I'm going to quickly go over it. There's a lot of information here. Shh. Thank you. Come on, we've got 5 minutes, guys. We're nearly done. Can I have you all focused? We've got 5 minutes and we'll get through this together. Right, a green chemical indicator shows a change in concentration. A green indicator shows changes in concentration of carbon dioxide in a solution. Now, important bits. Green, CO2 is normal. Yellow, CO2 is... Are you muttering? Come on, guys. Thank you. It's very distracting. It's quite difficult to be up here trying to talk to you when I hear muttering. Thank you. The indicator is blue when CO2 is very low or when there is none. So, and it says, gives you a bit more information, it does not harm aquatic organisms. That's things living in water. They investigated the balance of respiration and photosynthesis using a snail and pondweed. Now, they set these tubes up here, and then the colour changed in each tube, and it tells you the colour they've changed. Now, before I even start this, I have a look at what each one of these tubes is doing. So before I even look at the questions, I know it's to do with respiration and photosynthesis. So I'll look for where photosynthesis is occurring. Okay, I've got my pondweed. And oh, wait a minute, really important bit here. After 24 hours in the light. Light is really important because in sunlight, what process occurs? Photosynthesis. Okay, so important. Shh. So here, I've got pondweed here and pondweed here. So photosynthesis must occur. Okay, in both of these. Oopsie, can't write. Happy with that? Now, so I've done photosynthesis. I've said where that happens. Now, it says respiration. Okay, where's respiration? It's in daylight. So do plants respire during daylight? Plants respire during daylight. No, they don't. When do plants respire? Do plants respire or not? Every living thing has to respire. We know that we respire all the time. Animals respire all the time. When do plants respire? During light or not? Right, if you don't know, shh, is there anybody brave enough to tell me? Anybody know? Right, plants respire at night and they respire during the day. But here, this is only photosynthesis because it's in daylight. Plants only respire in the dark. So the snail is an animal, it will respire. And it's in there as well, so it will respire. Right, respiration. Photosynthesis gives off, it takes in CO2 and gives off O2. So, sorry, photosynthesis takes in CO2. Respiration gives off CO2. Now, why have I got this one here on its own with nothing in it? What do we call it when we've got one thing that we don't change anything in? It's got the indicator solution. Nearly done.
Not have anything away or move. Thank you.
2 seconds. What we call this a control. Okay, so we've got those there. Bear that in mind. Do you want me to finish this or stop, miss? Stop. I'll just do that. Right. So, right, the purpose of tube A, it's to act as a control. Okay, but what you need to do with this question, I suggest that you take these to your next science lesson, and what you need to do with these questions is, you need to say, when photosynthesis is occurring, CO2 goes up, so therefore, CO2 is used up, so it turns blue, low CO2. This one, respiration, increases CO2, turns yellow, high CO2. And finally, photosynthesis and respiration are both occurring, so CO2 goes up and CO2 goes down. So they are balanced. Balanced. Right, thank you very much. Sorry we rushed that at the end.